All right, we've already talked about why atoms bond, and you should know by now we say, do they bond for the same reasons humans do? We bond to be happy. We bond to add stability to our life. And we've already talked about this. For an atom to be stable, it needs a full outermost shell, full of electrons. All right, but I think I've emphasized this, but I really haven't had a chance to talk about this very, very important concept, which is atoms lose their individual identity when chemically bonded to form molecules. Boom. Again, really important. Atoms lose their individual identity when chemically bonded to form molecules. So, we will work through a couple examples that we've talked about in class so far. All right, so this should be review. Everything we've covered so far, you should really have down so that when we build on it in class, you know it inside and out. So when I show you this, you should say, oh yeah, I know all about this. Here we had a sodium atom with 1 valence electron, so it was pretty unhappy. We had chlorine with 7 valence electrons, so it was unhappy. We had an ionic bond form with the transfer of electron, and that produced a sodium ion, a positively charged cation, and a chloride ion, the anion, with the -1 charge. So this should be old hat. So let's apply this statement. Elements just completely lose their identity after they form a chemical bond. So let's start with pure elemental sodium. So sodium, you should know, is atomic number 11. What you might not know is this is what sodium looks like in elemental form. It's sort of this silverish gray metal. Now, I think almost all of you have had high school chemistry, but did any one of you have a real wackadoo high school chemistry teacher that threw sodium in water? All right, well, if you didn't, this is what you're missing. We're going to look at when you take pure sodium and throw it into water, what happens. There we go. Pure sodium in water. It's fizzing. That's weird. And now it's on fire. What? You throw a piece of metal in water and it catches on fire? Holy cow. Oh my gosh, it just exploded! Did this piece of metal really just explode when you threw it in water? Okay, that is just insane. That is totally insane. And now they play it back in slow motion if you want to see it. It takes 15 seconds. We can watch it. It's sort of cool. I mean, if you throw a nickel in water, it just doesn't catch fire and explode. Okay, that is just crazy. That is just crazy. All right, we will go back to our originally scheduled program. All right. I'm sorry. No, did not want to do that. All right, we'll try it again. All right, so here we were. You throw sodium in water, it explodes. Pretty crazy, right? What about chlorine? Does anybody know what elemental chlorine looks like? Well, elemental chlorine is actually a gas, and it has this sort of olive green color. It's greenish yellow, and it's okay when you put it in a test tube, that's a Florence flask if you care. It's okay when you dissolve it in a swimming pool because chlorine kills germs. Well, it kills a lot of things because chlorine is a poison. So when you dissolve chlorine in a swimming pool at very low concentrations, it kills the germs and makes it safe. However, unfortunately, various governments around the world have released chlorine gas in large quantity as a form of chemical warfare. Most nations of the world have treaties to prevent this because this is just a horrible use of this. And again, it's bad enough when World War I, you had people wearing gas masks because you didn't ever know when gas was going to be poison and gas would release. But if you followed the news a couple years ago in Syria with all the wars, the government was releasing chlorine gas against its own civilians. And adults were getting sick, children were getting sick and dying. All right, so I don't know, this sort of puts things in perspective. I mean, we are so inconvenienced by this pandemic, but you know what? We don't really have it as bad as some people around the world. But anyway, you get the point. Chlorine, it's a deadly poisonous. All right, so we take sodium, which explodes when you throw it in water. All right, and then we take and combine it with chlorine, which is this poisonous greenish yellow gas, and what do we get? We get salt. Salt is not a gas, it's a solid and it's white. And let's see, let's think about this. Does salt explode when you throw it in water? Of course not. You dissolve salt in water all the time. But what about poison? Is salt a poison? No, salt's not poison to Humans, we consume it actually, especially we Americans in large quantities. Well, if it's not poisonous, is it bad for you? Well, notice I changed the word bad to unhealthy because as we start to explore the limits and nature of science this weekend, we'll realize questions of what's good and bad are really outside the realm of science. Those are ethical questions, and we don't deal with that in science. All right, we just study the natural world, right? So I changed it to is salt unhealthy for you? Well, salt, believe it or not, these sodium ions, salt is necessary for human life. So personally, I don't think that's bad. I like to be alive. So the bottom line is a little bit of salt is healthy for you, but frankly, the way most Americans consume it, it's in unhealthy levels. So there you go. Sodium and chlorine have totally lost their identity when they're chemically bonded to form salt. So let's look at the other example we talked about in class, hydrogen and oxygen. So here we have hydrogen, elemental hydrogen is a gas combined with elemental oxygen, and we get water. And you should really have the structure of water memorized. You should know these are covalent bonds, and we are going to talk about water in great detail, so try to get this down by our in-class lecture. But anyway, back to our story. Elemental hydrogen. All right. Let me ask you this. Is it flammable? Have you done a flame test for oxygen in high school chemistry? Or maybe you've heard of, boom, the Hindenburg? This was a hydrogen balloon. Yes. The answer to this question is hydrogen is extremely flammable. What about pure oxygen? Is elemental oxygen what we need to breathe to live? I have asked you this question for. Is this the form of oxygen, O2, that's in the atmosphere? Is this what we need to breathe to live? And the answer, if you didn't find it on your own already, is yes, this is absolutely what we need to breathe to live. Now, if you want extra credit, you could tell me why we need to breathe oxygen to live. Because what I've found, students have heard since, kindergarten, first grade, they need oxygen to live. But when I ask people why, they're like, I don't know, you need it to live. Well, why? You need it to breathe. No, you breathe to get oxygen. And this could be a fun experiment you could do on your own if you're bored in the dorms or something. Call up the 3 smartest people you know. Make sure they're brilliant, but they can't be in the medical profession. They can't be a biologist. They can't be a doctor. But they can be any kind of scientist, engineer, politician, anybody you know who's really smart. And say, hey, do we need oxygen to live? And they'll say, well, yes, of course. And then if you say, why? Trust me, people are going to stumble around. Oh, you need it to breathe. No, we breathe to get oxygen. You need it to live. Well, why? Anyway, see what you can find out on your own. If you find the answer, I need it in a form that the general population can understand. Don't give me any kind of scientific mumbo-jumbo with words that most people don't understand. All right, so back to our story. Oh, I forgot. Public service announcement. I've heard, so we all agree, right? You need oxygen to live. You need O2, what's floating around the atmosphere. So I've heard a lot of people say, or people on the internet, oh my gosh, yeah, a mask might protect us against the virus, but it's going, I'm not going to get oxygen to live and I'm going to faint. So is this true? Does wearing a mask keep you from getting enough oxygen? Because this would be pretty serious, Well, think of surgeons. This is why they're called surgical masks. All right. Oh, I guess we've all heard of that. People are in the middle of a critical heart operation and the surgeon faints for lack of oxygen. No, we haven't heard these stories because they're not true. See this guy here, he knows, that story's not true. That's a stupid story. All right, surgeons wear a mask all the time. And I put in this picture, look at this guy. He's wearing this surgical mask, perfectly illustrating how it's form-fitting over his face. So, yes, oxygen. Oxygen is only 2 atoms big. So plenty of oxygen can get in, and he can perform his surgery. All right. Viruses are made up of thousands of atoms. They're way bigger than oxygen molecules. So yes, oxygen can easily pass through these surgical masks. That's why surgeons wear them all the time when they have to think really hard to do surgery. And guess what? They don't faint. So yes, your mask can let oxygen come in and your carbon dioxide to go out. That's only 3 atoms. And if you wear it correctly, all right, the big old virus particles will not get in. All right. So yeah, please wear your mask. We'll all be happier and safer. All right, so back to our story. When we combine hydrogen, which is highly flammable, with oxygen, which we need to breathe to live, we get the compound water. Is water flammable? Well, not usually. You know, there's an old joke about, you know, the river up by Cleveland catching on fire, but that's only because it was polluted. So yeah, polluted water, well, it's not even the water that catches on fire, it's the pollutants. So yes, pure water is not flammable. Can you breathe it to live? No. Water is H2O, but once again, the whole point of this little lecture is to emphasize oxygen has lost its identity. Here, let me switch to a laser pointer. All right, O2, this is what we need to breathe to live, O2. Once it is combined with hydrogen, once it's water, it's not oxygen anymore. It's part of water. And you cannot breathe water to live. All right, you cannot breathe water to live because it's not oxygen anymore. All right, this is what we need to breathe to live. All animals need to breathe oxygen to live. Well, what about fish? Can fish breathe water to live? Okay, write it down in your lecture guide. Can fish breathe water to live? Yes or no? Do, 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 do. The answer is no. Oxygen has lost its identity when it's in water. If you put a fish in pure water, it will die. What fish breathe is dissolved oxygen, O2. So if you have a healthy lake or stream, this should be very interesting to the EVB majors and sustainability majors, even in biology majors. Fish breathe the O2 that's dissolved in the water because they're animals just like we are, and their gills are able to extract the oxygen. But if you have pollution that drives out all the oxygen, the fish will die. Or if you would just take pure water and boil out all the gas and somehow make sure there's no oxygen in there, if you put a fish in pure water, it would die due to lack of oxygen. All right, so I hope there's a fun fact. Maybe you can use it at a party. I don't know. Not that you're really allowed to have parties, or maybe you can share it with your parents to show that you learned something. But I hope this has been helpful, and I will see you in the next video.